Now that we're more familiar with the LCM of rational expressions, we're going to use those LCMs to add or subtract rational expressions. In order to add or subtract fractions, the denominators have to be the exact same, and then we would add or subtract across the top, across the numerator of those fractions, if the denominators are the same. So in number 1, our denominators are the same, and since we're adding, we can just add straight across the top. So this can be rewritten as 6r minus 5 plus 4r plus 2 all over 8a. Now in the numerator, we're going to combine like terms. 6r plus 8r is 10r. Negative 5 plus 2 is negative 3 over 8a. If we had anything to simplify here, we would, but in this case, there's nothing more to do. In number 2, we have different denominators, so we need to figure out the LCM first. On the left side, we have a and b, a times b. On the right side, we just have b. We're missing an a. Our LCM here is going to be AB. Since we're missing an A on that right-hand side, we're going to multiply the top and bottom by whatever we're missing. So I'm going to multiply the top and bottom here by A. So this can be rewritten as 7 over AB minus 9A over AB. Here, A over A is just our fancy 1, like what we were doing when we would rationalize the denominator with radicals. Here, our fancy 1 is A over A. Now we have the exact same denominator, so we can subtract across the top. 7 minus 9a over ab, and there's nothing to simplify. Z minus 1 over 3z minus z plus 1 over 2z squared. So on the left, we have a 3z in the denominator, and on the right, we have a 2z squared. The left side is missing the 2 and an extra z. The right side is missing the 3. So our LCM here is going to be 3 times 2 is 6, and we need 2 z's total. So on the left side, we're missing a 2 and a z, so we're going to multiply the top by that 2 and the z. That way we can get our LCM of 6z squared minus, and then the right side was just missing the 3, so we're going to multiply the top and bottom by 3. And now they have the same denominator, so we can subtract across the top. We've got 2z times z minus 1 minus 3 times z plus 1 over 6z squared. I'm going to simplify the top by distributing and combining any like terms. So when I distribute the 2z, I've got 2z squared minus 2z. When I distribute the negative 3, I have negative 3z minus 3, still over 6z squared. That leaves me with 2z squared minus 5z minus 3 over 6z squared. In number 4, the denominator on the left is x minus 2. The denominator on the right is x plus 3. The left side is missing the x plus 3, so I'm going to multiply that to the top. So now on the top on the left, we have x plus 3 times 1, which is just x plus 3. And then the right side is missing the x minus 2, so I'm going to subtract 4 times x minus 2. And our LCM is x minus 2 times x plus 3. It doesn't matter which order that denominator is in. Now we'll simplify. We have x plus 3 minus 4x plus 8 over x minus 2 times x plus 3. I'm going to keep the denominator in factored form. Simplifying further, x minus 4x is negative 3x, and 3 plus 8 is 11 over x minus 2, x plus 3.